I'm Leif, I work at Fraunhofer, and I want to talk about auto AR, which is mostly linked to a car at the moment, but not necessarily in the future. But at the moment it's that. We're using data that we have from processes in BIM and 3D CAD and put them on a car and put them outside. And before I go into the details of the talk, I just wanted to show you a quick video. If you could please press the start button for me. So what's this and how it has been built? That's going to be the content of my talk. Just a quick background slide for my company. I'm from Fraunhofer FIT, which is one of 69 Fraunhofer institutes. We are the largest research organization for applied research in Europe. You might know MP3, which is from one of our partner institutes. And I'm from FIT, as I said, which is the Institute for Applied Information Technology, basically HCI, corporation systems and so forth. We are on one of the largest IT campuses in Germany, near Bonn. Our heads are Professor Jarke and Professor Decker, who previously chaired the Digital Enterprise Research Institute, DERI, in Ireland. We've been doing all kinds of augmented reality related research starting from the mid-90s really. So the first one, or late 90s, was the M-Cube stage planning thing. So we had the Sonic Lastron as an enabling device back in the day, and all the researchers everywhere in the world took it and attached it to high performance computers and made AR. So we made AR for stage planning for rock concerts, which was a big C-bit hit back in the day. We applied it to the top left to the architecture domain, partnering in large EU project Arthur with the bureau of Norman Foster, who was on it, and that's the Swiss Re Tower in London. We put it into building maintenance uses and so forth. Lots of game stuff. I've been heavily involved with mobile gaming, pervasive gaming, stuff like that. We put it in the city, we put it underwater and into stage performances and things like that. And at some point, I kind of reflected upon what we did so far. Everything became so small. The mobile phones you have in your pocket are 10 times more powerful than the computers we started doing this kind of stuff on. So why not take more complex, more expensive, bigger stuff on board? It will come smaller anyway, and do new crazy projects. So that's what we did. So we thought, coming from our history of projects in VR, AR, and CSTW, and we had innovation projects in the construction industry in the very beginning, and the mobile location-based stuff I've been talking about. How can we apply it back to the construction domain? That seemed like an interesting endeavor for me about 5 years ago from today. And we had an initial cooperation with Bauhaus University in Weimar. At that point, they were using one of our gaming technology to build a virtual pavilion, an augmented reality pavilion for one of their yearly show open houses. We had a joint project with SITLab New Zealand, and at the time of our research exchange projects with them, the big earthquake happened in Christchurch, and then we thought, okay, how can we apply something like mobile augmented reality to analyzing and bringing communication about what the city was like and what the city was going to be. And I thought there's going to be so much more in that domain, coming up with building information modeling that I applied for a project which we initially presented here in Munich 2 years ago, but today I've got a bit more examples that I can talk about. So the story is, nobody can read plans. That was always the case. It will always be the case. Of course, there are a few experts who can do it, but nobody really can read the blueprints, and that's why all the big projects fail quite often. There's a misunderstanding. That's why people build miniature models like the one you see here. If you've got a large construction site somewhere, probably someone will have a building model, and you can go, okay, I understand what you want to do. Maybe you are even bigger, and you've got an expensive corporate video about that. Maybe it was ray traced about something in Dubai or whatnot. You never know. The cons is that's all quite static information. If you want to change something in your plan, you will have to re-render that again, or you will have to remake that wood model, and that's doable. You know, people do that, but we thought maybe we can do something with AR technology in here. And a cornerstone for that was the advent of building information modeling, which is nothing else than a new way. Well, a new way of understanding each other on construction site. It's not a completely new way of thinking, or maybe it is, I don't know, but at least people have the same understanding because they're always up to date with their data. A BIM is not a software. That's quite important for one of the leading BIM guys in Germany, Wernicke. He said it's a method, it's not a software. It's a way of working with digital data over the whole construction period, from the initial invention up to tear down and rebuilding something else. And for me, it's 3D geometry. That was one of the main incentives for me to go into that. Because with 3D geometry we can do nice AR and VR, and with all the gaming projects that we did beforehand, we did a lot of game programming and game modeling. This time I said we're not going to do any game modeling at all, so we're just taking whatever the architects made and cooperate with them and put that into our gear that we had to invent for this project, taking from what's readily available on the market. And device workflows so that is doable. So we've got a 360-degree panoramic camera, apparently the same that Google chose for their Street View stuff, but we're not, cooperating with Google, or actually also not with Audi. I have to mention, because the guy from Audi was just before me. I'm one of the innovated Audi guys. We did this on our own, even though we have Audis and BMWs. And just commercial 3D engines and various kind of displays and so forth. And we can be anywhere in Germany or actually in Europe within a day, because it can even go onto a plane actually. It's just a standard rooftop thing that we can take onto site. Before we go onto site, we have a 3D model. That's our own building there. We have to convert it a little bit. Usually the architect's data is a bit high polygonal, and also in places where you wouldn't expect, maybe in the chairs. We found out, so maybe the chair might have 5 million polys or something like that, and maybe that's not so important for your exterior view. So we slim that down a little bit so it's manageable, but the mobile devices and the high performance computer we have on board are really quite powerful. Then we drive around the site. You've seen it in the video. It's mostly actually recording on site. So the use case is mostly we do something on site, like a camera team. We take it to the office and we take it to the client afterwards. You could experience on site like you can also watch through a camera lens, but it will be for other people, just like with the camera guy. You're seeing me and you're taking a picture of me, but the picture is for somebody else afterwards. So yeah, that's what you can do. It's partly already covered in the previous slide. What we can record while we are outside is, of course, the video streams in 360 panorama, and we also record the movement of the car and the orientation of the car, and also the orientation of the headset. So we can play that back exactly as it happened, and we can also decouple the head-mounted display from the car's orientation, so we can reorient ourselves as if we were passengers on the car, and just look around. And that's what you usually do in the office, or if you play it out as an interactive 360 experience, that's what your client could then do. Yeah, but also it's quite often it's video capturing, so we kind of get nice views of what we captured on site. And if somebody comes with an updated plan, which happens, we can make an updated video or 360 experience without going on site again. So we only have to do the video basically once, and then we can devise everything else and derive it from that. I've got more examples to show you and some wrap-up slides afterwards. So the initial talks we had also led to cooperation with a contract from Volkswagen Financial Services, which we presented at previous talks. I'm not going to present that here today. If you're interested, there's material from the augmented reality in the industry in Berlin a year ago, and also of the BIMIT, the German BIM ID project. There was a couple of symposiums. I think we were on the third one. You will find the slides. Come and grab me afterwards if you want to have them somehow. No problem. And there's also a new video. We just built a new building for ourselves on our campus near Bonn. And we visualized that. And actually, maybe we played the video first and then I can explain afterwards what's interesting about that. So if you could please start the video for me. We didn't have the digital elevation model and there was no money for that, so disregard that. There's some occlusion problems with the ground. So yeah, there's two interesting things in there. Just quickly mentioning the least important is the lunchtime break walk of my colleagues. When I showed this video to my colleagues, everybody went, yeah, but we always walk there. Now we have to walk around the new building. So that was one little nuisance. And the bigger nuisance was that the new building is very close to the other building and nobody previously noticed that, or everybody said it's not an issue. We had one architect, for him it was an issue, and it was a big pleasure for him to have the topic opened again after the big bosses saw the video, so they couldn't discuss these things again, and said, yeah, actually it's too close, the architects have to do one more iteration. You saw that then when I was driving through with the car at the back entrance, which is actually the goods entrance, and the Sprinter vans need to arrive on a daily basis, maybe even a 7.5 tons van needs to arrive, and it barely fitted a car, so there will have to be a redesign on that building, but that's cool. It's a good use case for me. So yeah, the data that we have in BIM and 3D CAD, just wrapping up the session really for me, it's there, you can use it if you got the experience to do it like we have. It usually takes you a couple of days, maybe weeks, depending on what the client has and client wants. And we think that solutions like this can support your understanding of what you're planning to build, or maybe already building. Mostly it's in the planning stage. So you might have a complex restructuring of a campus like we had in the first video with Fiducia. A couple of buildings came down, a couple of buildings are going to be added, and nobody really understood what the new campus was going to look like afterwards. They were much more secure in their decision to invest more than 100 million euros to restructure the campus. We had another customer saying that it opened up my discussion about the facade. So it looked cool in the plans that I got from the architect, but when I saw the other houses that I only got from the panoramic image, I felt it didn't really fit and we had to change something on the facade. And you can also check, like in the video that I showed at the last, the proximity to other buildings and their uses, like the goods entrance and stuff like that. So if you think this is a cool thing and you would like to build something like that, I'm all here talking to you. Please get in touch. We can probably do something like that for you if you want it. And yeah, find us on Facebook, Twitter, on our website. And if there's any questions, I'll be happy to answer them. Thank you.